Welcome to Insights into the Industrial Revolution, Part 5, The Age of Iron. If there are three things that exemplify the Industrial Revolution for most people, they are the steam engine, the cotton industry, and the iron industry. I gave an overview of the development of the cotton industry in my video on the factory system. In this episode, I cover the iron industry during the Industrial Revolution and its inextricable link with the steam engine. The smelting of iron. Iron was traditionally smelted using charcoal, but charcoal was expensive. Experiments with coal failed, but from 1709, Abraham Darby successfully smelted iron using coke. Coke is made by heating coal in the absence of air, similar to the way that charcoal is made from wood. Although still expensive to make, coke was cheaper than charcoal and it burns hotter than coal, making it suitable for efficient iron smelting. Abraham Darby's company prospered and was later called the Coalbrookdale Company. It survived for over 100 years before being absorbed into other iron companies. An iron foundry existed on the original site until 2017. It took 40 years for iron smelted with coke to take hold in the industry, but when it did, the Industrial Revolution really took off. John Wilkinson. Isaac Wilkinson was an experienced ironmaster who learned the art of smelting iron with coke in the 1720s. Isaac's son, John, was born in 1728, and in 1745, John entered into partnership with his father. In 1755, he set up business on his own account and, with partners, built a blast furnace in Shropshire in 1757. And in subsequent years he built iron foundries and works across the West Midlands. John Wilkinson was a prolific inventor of new processes for the iron industry. He improved the design of the blast furnace to make it more efficient, and in 1774 he patented a machine for boring iron guns from a single piece. This technique made the guns safer and more accurate. Just as importantly, this invention would enable the manufacture of efficient and safe steam engines. John Wilkinson became the exclusive manufacturer of the piston cylinders for Boulton & Watt steam engines. His iron boring machine enabled Boulton & Watt to make precision-engineered cylinders and pistons for their steam engines. Wilkinson was one of the most successful ironmasters of the 18th century. As well as the iron boring machine, he invented a rolling mill and a hydraulic-powered blowing engine for blast furnaces. He owned several iron foundries and also invested in copper and lead mines. And he was a strong promoter for the building of the famous Iron Bridge across the River Severn. Opened in 1781, this was the first cast iron bridge in the world. In 1787, he launched the first iron boat in the world. By the mid-1790s, Wilkinson's iron foundries are believed to have been producing around 1/8 of the cast iron in Britain. Perhaps unusually for the age, Wilkinson was a good employer. He built cottages for his workers and their families, and he sought to ensure that miners who supplied him received a fair return. John Wilkinson, nicknamed Iron Mad Wilkinson, died in 1808 and, unsurprisingly, was buried in a cast iron coffin. Boulton & Watt. James Watt was a scientific instrument maker working in Glasgow. He developed an interest in steam as a source of power, and in 1765 he came up with a design for an improvement on the steam engines in use at that time. He continued his experiments and registered a patent for his steam engine in 1769. But he did not have the funds to develop it into a commercial enterprise. Matthew Boulton was a successful businessman based in Birmingham, in England. He was interested in the potential of steam power, and he had funds to invest. James Watt moved to Birmingham in 1775, and the firm of Boulton & Watt was created. James Watt brought his genius for steam engines, and Matthew Boulton brought more than money to develop Watt's ideas. He also brought a talent for business, and he brought extensive contacts in the engineering industry. One of those contacts was John Wilkinson, and we met him in the previous section. John Wilkinson had patented his metal boring machine the year before Boulton & Watt was formed. This machine enabled Boulton & Watt to make precision-engineered cylinders and pistons for their steam engines. The company of Boulton & Watt prospered with innovative sales techniques and a focus on engineering excellence. At first, their engines were mainly used for pumping, based on the up and down motion of the beam engine. However, in 1781, the company patented a gear, called the Sun and Planet gear, that converted the power to a rotative motion suitable for grinding, weaving and milling. By this means, Boulton & Watt steam engines began to power the factories of the Industrial Revolution. It's believed that Boulton & Watt had sold over 490 engines by the time their patents expired in 1800. Both Matthew Boulton and James Watt retired wealthy from the business in 1800. The firm of Boulton & Watt continued under the management of the sons of the two men. Matthew Boulton died in 1809 and James Watt died in 1819. The firm of Boulton & Watt continued, expanding into marine steam engines. In 1849 the business was renamed James Watt & Company. But the company closed down in 1895, its technology superseded by other types of engine. Henry Cort. Henry Cort had worked as an agent for the Royal Navy before he got involved in the iron industry. In 1780 he used his Navy contacts to secure a contract to recycle their iron. He also managed to secure a loan from Navy funds to establish his business. In 1783 and 1784 he registered patents that mechanized the process of refining cast iron to wrought iron. His technique reduced the carbon content of the cast iron and rolled it into wrought iron. Cast iron is brittle in tension and prone to fracture, whereas wrought iron is worked iron. Wrought iron is more refined and is hammered or rolled to improve its quality. Wrought iron is strong under tension, but was much more expensive than cast iron until Henry Cort developed a method to mechanize its manufacture. Henry Cort's process was improved by other iron masters, and their mass production methods greatly reduced the cost of wrought iron. Henry Cort himself did not prosper. It turned out that his loan from the Navy had not been properly authorised, and the money was recalled, bankrupting him. He was later awarded a government pension for his invention and died in 1800. Henry Cort and those that came after him made wrought iron affordable and greatly stimulated the Industrial Revolution, since cast iron was not suitable to the engineering needs of the time. One important example was the invention of mass-produced wrought iron rails by John Birkinshaw in 1821. Wrought iron rails were able to withstand the moving load of a steam locomotive and train. Before that, cast iron had been used for rails, but it was brittle and broke easily under the weight of the engine. Without wrought iron rails, the railway age could not have happened. George Stephenson understood the importance of John Birkinshaw's invention and used his rails in the Stockton and Darlington Railway in 1825 and his later railways. James Beaumont Neilson. Born in Glasgow in 1792, James Beaumont Neilson worked in the coal and iron industries. He experimented with the smelting of iron and realised that blasting air heated to 600 centigrade into the furnace was much more efficient than the methods previously used, cutting consumption of coal by a third. Patented in 1828, Neilson's hot blast method allowed coal to be used in iron smelting rather than coke. It also allowed black band ironstone to be used as a source of iron ore. Since coal was much cheaper than coke, and the previously unusable black band ironstone was prevalent in the central belt of Scotland and elsewhere across Britain, Neilson's advances opened up the massive growth of the iron industry in the UK. Although not widely known today, Neilson's advance was certainly one of the most important developments in the Industrial Revolution. From iron to steel. Steel is an alloy made primarily of iron and carbon that is stronger and more durable than pure iron. Steel has been produced for thousands of years, but hand-worked on a small scale. That made it expensive. Henry Bessemer was born in England in 1813. He made a fortune from his invention of bronze paint, and he turned his attentions to the manufacture of plate glass in the 1840s. His glass business was not successful, but he gained experience in the design of furnaces, and that would help his next business. From 1850 to 1855, he experimented with the production of steel, patenting his method for the mass production of steel in 1855. By coincidence, the American iron manufacturer William Kelly invented a similar process and registered his patent in the United States in 1857. This meant that Bessemer was not able to register his patent in the United States. However, William Kelly went bankrupt in 1857, and Bessemer bought his patent and began selling the license to manufacture steel in the United States. William Kelly received a royalty of about 5% of the licensing fee, while Bessemer received the rest. William Kelly died in 1888. Both methods involved blowing air through molten iron to burn off the impurities and create steel. Bessemer's process lowered the cost of producing the steel, leading to steel being widely substitute for cast iron and wrought iron. In Britain, Henry Bessemer licensed his method to a number of ironmasters. He continued to work on improvements to the process and established his own steel works in Sheffield. He became fabulously rich. Henry Bessemer was a prolific inventor and registered at least 129 patents between 1838 and 1883, in every field from weapons to postage stamps to sugar making, and of course in iron and steel making. Knighted by Queen Victoria in 1879, Henry Bessemer died in 1898. The open hearth method of steel making superseded the Bessemer method by about 1900, although Bessemer's method continued to be used in Europe until the 1960s. The Age of Iron. I close this insight into the Industrial Revolution with some statistics. In 1770, there were less than 30 iron foundries in Great Britain. The Napoleonic War stimulated an increase in iron foundries to around 150 by 1800. The railway boom further boosted the iron trade, and there were about 300 iron foundries by 1830. The peak of the iron trade was in the 1850s, with around 500 foundries in Great Britain. By the 1870s, there were 600 ironworks in Britain, but steel was starting to replace iron. In 1856, there was only one steelworks in Britain. It used the Bessemer process. By 1870, there were around 30 steelworks, with Sheffield and Glasgow key steel hubs. Around 250,000 metric tons of steel were being produced, and that was about 40% of global output. By 1900, there were around 80 steelworks in Britain, but the United States and Germany were producing more steel than Britain, where output was about 4 million metric tons. As the First World War started in 1914, there were around 100 steelworks in Britain. These were much larger than any that had gone before. About 7 million tons of steel were produced in the UK at this time, but this was only 13% of global output. The United States now produced 40% of global steel output. And that is the story of the Age of Iron. Iron was the backbone of the early Industrial Revolution. Iron rails enabled the railway age. Iron-built machinery enabled mass production, and iron tools revolutionized agriculture. Steel drove the second phase of the Industrial Revolution. Steel was stronger and more versatile than iron, and it replaced it in most applications. Steel railway tracks were more durable than iron ones. Steel hulls enabled larger and faster ships to be built. Steel girders built bridges and skyscrapers. And steel weapons facilitated the slaughter of the First World War. The Age of Iron, and later steel, was central to the Industrial Revolution. Iron and steel became the foundational materials for machinery, transport, infrastructure, and military power. They enabled the rapid growth of industry, cities, and global trade. making Britain the world's leading industrial nation in the 19th century. Thank you for watching this video on the Age of Iron. Goodbye.